So you need to remember what the equation for a line is, and that is y equals mx plus b. That's the mathematical description of a line, and m is the slope and b is the y-intercept. So slope is this is the way you write it, the change in the y direction over the change, that's just a little triangle, means change in. That little triangle means delta. It's the Greek letter for delta, and delta means change in. So the change in the y direction on the top, the change in the x direction on the bottom, that is slope. And if you have two coordinates, x, y, and x, y, and that's usually one is given a 1 and the other, a 1 and a 1, a 2 and a 2. So this is, you had 2 points on this Cartesian coordinate plane system, and you wanted to find what the slope of the line that those 2 points, if you connect those 2 points, the line that creates, and you want to find the slope. The way you find that is to find the amount of change in the y and the amount of change in the x. So remember, we call this, another way to call this is rise over run. The rise is on the vertical, that's the y. So we start with the y on top, the change in y. So it would be y sub 1 minus y sub 2. And all we're doing is finding the amount of change, the delta between these 2 points, or these 2 coordinates for these 2 points. This was our first y that we chose, and this is our second y. So the first one goes there, and the second one goes there. And then we find the horizontal change, and the same way, the x sub 1 minus the x sub 2. And that's also written as rise, the amount of rise, the vertical. There's our etch-a-sketch over the run. That's along the horizontal direction. All right, and then the y-intercept is the b. So we have y equals m, the slope, x, plus b, and b is the y-intercept. That just tells you where the line crosses the vertical axis. Y is the vertical axis. So wherever that line crosses, that's the point. So you know that you have x, y. So if it's crossing the y-axis, the x coordinate must be 0. So it's going to be 0 and then a number. That number is b. And it means when x is 0, what is y? And then we get into graphing coordinate points and lines. I just wanted to show you this right here. You can see that these 2 lines are different in terms of their slope. So let's look at this first line. It's kind of a red line right here. We want to define this line. So if we were just visually inspecting it, every point along this line has a coordinate, and this line obviously keeps going in that direction, and in this direction we've only put a line segment on here. Let's say we just randomly pick this point right here. What is the slope? Well, you can see if we go 1 unit to the right, what do we have to do to get back up onto the line? We go 1 unit vertically, and now we're back on the line. If we go 1 unit to the right again, we have to go 1 unit back to the line. So the slope of this first line is 1 unit of rise for 1 unit of run. It's 1 over 1, which is the same as saying the slope is 1. Now, if I went 1, 2, 3, 4 units this way along the horizontal to the right, how many do you think I would have to go to get back onto the line? 1, 2, 3, 4 units vertically to get back to the line. So that's 4 on the rise and 4 on the run, which 4 over 4 is still 1. So the slope of this line is 1. So we're building the definition of the line, y equals mx plus b. We've now figured out the m part of this line. So it'd be y equals 1x plus b. You don't have to put the 1 there, so you could just say x plus b. But now we have to figure out the b part. Where does this line cross the y-axis? Because it's the y-intercept. And it crosses it right here at this point. Well, what is that point? It's 2 units down, so that's -2. So the y-intercept for this line is -2. So we end up with y equals x minus 2. That is the definition of this line. X minus 2. That's the definition of that line. Let's do this. And you can solve this in either direction. You could pick x coordinates, x values, and solve for y, or you could pick y values and solve for x. But let's pick x values. If we choose 2 as the x, 2 minus 2 is 0, so the y would be 0. If we pick 0 for the x, 0 minus 2 is -2, so y would be -2. If we pick -2 for x, -2 minus 2, so we have -2, -2 is -4. And we can plug those in and verify that these are actually on the line. These are the coordinates that both define the line and solve the equation. So if x is 2, these are coordinates now. So we go over 2 places on x, 1, 2, and we rise 0. We go over 0 and down 2. Well, we already found that one. That's the y-intercept. We go to the left 2, right there, and down 4. 1, 2, 3, 4. So we found that point right there. And every point on this line will solve this equation, y equals x minus 2. All right, now let's look at the other line, figure out the slope on this, and you can start anywhere. Let's pick this point right here. The run, 1 up 2. We went 1 to the right, and then we had to go 2 in the vertical direction to get back on the line. 1 to the right, 2 to get back on the line. So for this second line, our slope, 2 in the vertical direction, 1 in the horizontal direction, which is the same as 2. That is our slope. So now we know y equals mx, the slope is 2, plus b. And we can visually inspect where this crosses the y-axis. It's 1, 2, 3, 4, 5 in the positive direction. So our definition of the line is y equals 2x plus 5. And that is the definition of this blue line. Y equals 2x plus 5 is the definition of this line. And we could do the same thing if we were to pick coordinates. And really you only need 2 coordinate points to define any line. So all we'd have to do is pick 2 points. We already know 1. 1 is 0, 5. So all we have to do is find one other point, and we just plug that in. So let's say we picked -5 for x. -5 times 2 is -10. -10 plus 5 is -5. So if we went 1, 2, 3, 4, 5 to the left, -5, and then 1, 2, 3, 4, 5. That's our -5, -5. Now we have these 2 points. We had this one, and we could define the line. If we knew the slope, which we did, we don't even have to do that. We could just start at one point and then use our slope. It was 1 to the right, 2 up. Okay, that's enough about that. All right, another principle that we're going to need to talk about is graphing inequalities and boundary lines. And I'm just going to say a little bit about that. If you come back here to this graph that we were working with, if you're graphing an equality, everything on the line solves the equality. So this was the equality, y equals 2x. But what if it were y is less than 2x plus 5? Well, this line would no longer be a line, it would be a dash, because it would be everything less than that, not what is equal to it. When it's equal, it's just every point on the line solves the equation. When it's less than or greater than, the line that you would otherwise draw as an equal becomes dashed, and that indicates that it's not, the answers are not on the line, it's everything below the line if it's less than. So it would be all points below this line would solve it, or all points above this line. So everything in this shaded area above the line would solve one of them, and everything below the line would solve the other. And then sometimes, like in this problem, you are given actually a boundary on both sides. So you'll have a definition of what would be that line, and then a definition of what would be this line. If it were just one equality, it would be everything above it. If it were the other inequality, it would be everything below it. But when it's set up between, where you have the shaded area in between, it means everything in between up to the line, but not including the line, would solve the inequality, or the 2 inequalities that you have, and that'll become clearer as we go on here. Okay, so let's answer the question now.